So looking at the warm-up, first thing I want to know is, what are the two formulas that we have for circumference? Circumference is equal to 2 pi r. And what is equivalent to 2r? What is the same length as 2r? The diameter. So the other possible equation that we could use for the circumference is circumference is equal to pi times the diameter. So pi times diameter, or 2 times pi times the radius. On question number 1, it tells me that we have a diameter of 12 meters. So I would take circumference equals pi times 12. When you do pi times 12, you get about what? If you do pi times 12 on your calculator, that's about how big? Yeah, it's right about 37.7. So which one of those answers, A, B, C, or D, is the closest to 37.7? B. Second one, number 4, diameter of x inches. So circumference equals pi times, I have diameter again, so I'm going to put x in the place of the diameter. I can't really multiply those together on my calculator because one of them's an x, but we know that pi is about how big? It's about 3.14, 3.14. So this would be about 3.14x. That's not precise, but again, we're rounding, we're approximating here. Which one of those 4 answers would be the closest? Yes, sir. 3, yes. Option C, 3x inches. Nice work. And then for the very last one, they actually give us the circumference, not the diameter, but they're asking us to find the diameter. So I would have 60 equals pi d. And then to find the diameter, I would need to divide both sides by pi. Which one of these choices, 20, 30, 15, or 45, is the closest to what you get when you take 60 and you divide it by pi? 20 is the closest. What did you actually get when you divided 60 by pi on your calculator? Yes, 19 point, what, like 09 is about what we get for the diameter. So 20 is the closest. Nice work on the warm-up. All right, we are going to switch gears and go into your notes for the rest of our time together. We are on page 6, which is the back side of the third piece of paper. Page 6 if the pages were numbered. Back side of the third piece of paper. And you want to be looking for the page that says 10-3 arcs and chords up at the top. That should be at the top side of the back side of the third piece of paper. So an arc is a section of the circumference of a circle. So an arc would be like this section of the circumference. And then a chord is a segment that has 2 endpoints on the circle. So a chord is a segment, it's a straight line segment, and an arc is a curved piece. And we're going to look at relationships between that curved portion of the circumference and the straight line segment that connects those same 2 points. The first thing that I want to talk about is if I have a diameter or a radius, and it is perpendicular to a chord. What does perpendicular mean? Perpendicular means what about these 2 pieces? They are intersecting, but it's very particular about how they're intersecting. At a 90-degree angle, yes. Perpendicular means forms a right angle. So if I have a diameter or a radius, and it forms a right angle with a chord, then it bisects the chord and its arc. So it cuts the chord and the arc in half. So anytime I see a segment that is touching the center of my circle, goes from the center to the edge, or it goes from edge to edge and goes through the center, if that is making a right angle with another chord in the circle, then it's cutting that chord in half, and it's cutting the arc that is being captured by that chord in half. All right. Second property of arcs and chords. Two minor arcs are congruent if and only if their corresponding chords are congruent. So if I have two chords that are congruent, then the arcs that they are capturing are congruent. And if I have two arcs that are congruent, then the segments that are joining the endpoints of those arcs would also be congruent to each other. And then the very last one, two chords are congruent if and only if they are equidistant from the center, so same distance from the center. We're going to look at these three properties of arcs and chords over the next 2 days. We're probably only going to get to 2 of them today, and we'll probably wait on that third one until tomorrow. All right, so let's start investigating this. Number 1, part A, it starts off by telling me that segments JK and LM are congruent. Well, here's JK. What part of a circle is JK? What would we call this segment? That's a chord, yes. Its endpoints are on the circle. It doesn't get another special name because it's not going through the center. And then we have segment LM over here. What would we call this part of a circle? That would also be a chord right here. Anytime it's a straight line segment connecting 2 points on my circle, it is a chord. And what do we know about these two chords? What do these markings tell me? They're congruent, and that's the same thing that they told me up here in the text. Segment JK, which is a chord, and segment LM, which is also a chord, are congruent to each other. And then it also goes on to tell me that arc LM, this is arc LM, is 75 degrees. Well, if arc LM is 75 degrees, and chord LM is congruent to chord JK, then how big would arc JK have to be? Has to be 75 degrees, yes. This arc is congruent to this arc. So the measurement of arc JK is 75 degrees. Part B, very similar. I know that segment AB, which is a chord, is congruent to segment CD, which is also a chord. I know that arc AB is 60 degrees, so this right here, the curved portion is 60 degrees. So what would have to be the measurement of arc CD? "60 degrees, absolutely correct. Because the chords are congruent, the arcs are congruent as well. So the measurement of arc CD is 60 degrees. Nice work. So if the chords are congruent, then the arcs are congruent. If the arcs are congruent, then the chords are congruent. Let's look down at number 2, part A. Tells me in circle C, arc DE, this one that I just outlined in orange, is congruent to arc FG, the other one that I outlined in orange. So those two arcs are congruent to each other. If those two arcs are congruent, then what would that mean about segment DE and segment FG? What would have to be true about those two segments? They would have to be congruent to each other. Because those are chords and they are touching the same endpoints as those arcs. So I have that segment DE is congruent to segment FG. That means the measurement of segment DE is equal to the measurement of segment FG. How big does the picture say segment DE is? 2x plus 6. So we're going to put that in the place of DE. What about segment FG? How big is that one? 5x minus 9, right here. We need to find what x is so that we can go in and figure out how big segment FG is. So to solve this for x, the first thing I need to do is get my x's to the same side. So I'm going to minus 2x from both sides. That would give me 6 equals what? I heard 3x. 6 equals 3x. Anything else? Minus 9, yes. 6 equals 3x minus 9. What would I want to do now? What would I do next as I'm solving this for x? Add 9 to both sides. What is 6 plus 9? 15. So I have 15 equals 3x. And then I need to do what with that? We need to divide. Divide by what? Divide both sides by 3. Oops. Scoot this all up a little bit higher here. And when I divide both sides by 3, we get that x is what? X is 5. Are we done? No, they asked us to find what? FG. Well, what was the size of segment FG according to the picture? 5x minus 9. So we're going to take the answer that we got for x, which was 5, and substitute it in. So I have 5 times 5 minus 9. What is 5 times 5? And 25 minus 9 would give me what? 16. So segment FG is 16. Part B is very similar. I'm going to give you guys about 2 minutes to do part B on your own, and we'll check back in. Yeah. So catch the video to catch up on the rest of the notes. Okay. I want you guys to be doing part B on your own. It is very similar to part A. Sorry, right here actually. You as well. Thank you, sir. On part B, how big is the x? X is 4. We know that segment RS is congruent to segment TV, so the measurement of RS is going to be equal to the measurement of TV. RS is 5x minus 9. TV is 2x plus 3. So then the next thing we do is get our x's to the same side. That would give me 3x minus 9 equals 3. Then I would add 9 to both sides. So I get 3x equals 12. Then we divide both sides by 3, and that's how that we get that x is 4. So if x is 4, how big is RS? 11, yes. Segment RS is 5x minus 9. We just found out that x is 4, so I have 5 times 4 minus 9. 5 times 4 is 20, and 20 minus 9 is 11. So segment RS has a size of 11 units. Very nice work so far. Let's go look at number 3. We're going to look at a slightly different property now. When I look at the picture in number 3, before I even read any of the words, the first thing I notice is this. What is that? It's a 90-degree angle. That's a right angle mark. Let's go back and look at the properties that we had. Which one of these properties talked about things being right angles? The very first one. It says if a diameter or a radius, something that touches or goes through the center, is perpendicular, forms a right angle with a chord, then it's cutting the chord and its arc in half. So I want to look back here at this. Where's the chord in this picture? Which piece is the chord? EG. Remember, chords have their endpoints on the circle. So EG is a chord. What would we call segment FD? That is a radius. So a radius is forming a right angle with a chord, which we just read means what is happening to this chord? It's being cut in half. So EH is the same size as GH. It's also telling me something about the arc. What would be true about arc EF as compared to arc FG? What would be true about this arc and this arc? They would be the same. They would be congruent, yes. That radius, where it's touching here at point F, that is the middle of that arc. All right, let's read what they gave us. It says that arc EFG is 120 degrees. So from here all the way around to here is 120 degrees. And they want me to find the size of arc FG. So they want me to find just this much. If I know the whole arc is 120, how do I find just FG? Divided by 2, yes. The measurement of arc FG is equal to half of the measurement of arc EFG. And arc EFG is 120 degrees. What is half of 120 degrees? $60. So arc FG is 60 degrees. So this little guy would be 60 over here, and this one would also be 60. What else did they want me to find? EG. EG is this entire chord right here from edge to edge. But I only know the length of EH. If I know how big EH is, how could I use that to find the length of EG, that whole chord? It's the same, so I can add 3.5 and 3.5, or that would be the same as multiplying by what? Multiplying by 2, yes. EG is equal to 2 times the measurement of segment EH. And segment EH is 3.5. So how big is segment EG? Seven. 3.5 plus 3.5, or 3.5 times 2. Let's come over here and look at part B. What is happening right here? What does that symbol mean? It means it's forming a right angle. And what would we call this segment right here? That's a diameter. We have a diameter that is forming a right angle with a chord. This chord right here. So what's it doing to that chord? What is my diameter doing to chord PR? It's cutting it in half. So PT is congruent to TR. And what's happening to my arc PR here? What is the diameter doing to arc PR? It's bisecting it. It's cutting it into 2 congruent arcs right there. Perfect. They tell me that arc PQR, so from here all the way around to here, is 90 degrees. Well, if that's 90 degrees, how big is arc PQ? 45 degrees, yes. Measurement of arc PQ is half of arc PQR. And PQR is 90 degrees, so I take half of 90 degrees, which would be 45 degrees. So the measurement of arc PQ is 45 degrees. How can I find the length of segment PR? How do I find the length of segment PR? Two times 6, yes. 2 times segment TR, which is 6. And what is 2 times 6? 12. So segment PR is 12. Very nice work. Let's look at one more for today. Down at the bottom, we'll finish this page out. Number 4 says we are to find the value of x. And the only thing they've given me to work with, other than these expressions right here, is that segment ZY, which is a chord, is congruent to segment XY, which is also a chord. If those two chords are congruent, what does that mean about arc ZY and arc XY? They are congruent. So what would the measurement of arc ZY be? (6x minus 20), yes. They want me to find the measurement of x. I know the measurement of arc XZ. I have an expression for ZY. I have an expression for YX. And how many degrees is it if I go all the way around the circle? 360 degrees, absolutely. So the measurement of arc XZ plus the measurement of arc XY plus the measurement of arc ZY equals 360 degrees. How big is XZ? What do we have for arc XZ? 76 degrees. What about for XY? 6x minus 20. ZY? 6x minus 20 again. And when I combine all those together, we get 360 degrees. So now I have some like terms to combine together. What are the like terms that I need to combine? 6x and 6x. What do I get when I combine 6x with another 6x? (12x). Do I have any other like terms to combine together? I have a negative 20. I have another negative 20. And 76. What is 76 minus 20 minus another 20? 36. So 12x plus 36 equals 360. I'm going to subtract 36 from both sides. What is 360 minus 36? 324. We're going to divide both sides by 12 now. What is 324 divided by 12? 27. So x is 27. Very nice work today on the notes. The homework that you guys grabbed on your way in the door is going to be due on Friday. You can do all of the front side. You can do 1 through 6. You can do some of the pieces in 10 through 15. We're going to do 3 examples tomorrow that are just like 10 through 15, so if you want to hold off on those, you can. But some of those pieces absolutely use what we were just working on, where the arc is being bisected by the diameter or by the radius that's perpendicular to it, and the chord is being bisected by the diameter or the radius that is perpendicular to it. We have not done any examples like 17 and 18. We will get to those tomorrow. So we'll do 3 examples that are like 10 through 15, and then we'll do a couple examples that are like 17 and 18 with the homework being due on Friday. But the entire front side can be done with what we've worked on today, and you can do some of the pieces in 10 through 15.